This is the part one of 2019 paper. Okay, have a look at a quantity in physics are classified as either vectors or scalars. Which of the following units only, have a good look at, only as a scalar quantity? So only, right? ms minus 1 can be velocity or the speed, so it can be either vector or a scalar quantity, so have to remove. The next part is the acceleration. It's a definitely vector quantity, have to remove. And the next part is the force. Force is definitely a vector, have to remove. And the next part is kgm minus 3. Let's see where is that one is. That means density is equals to mass over volume. That means kilograms over m to the power minus 3. So it's going to be kg m minus 3. If you don't know what is it really, you can remove these three answers and get this one. So really simple question. Now in the next part, once in orbit above the atmosphere, engine of the rocket is switched off. This is the Earth, and I have a good look at an object which is rotating around the Earth in a circular path. Right, something like this. A rocket satellite is revolving around the Earth in a circular manner. So in that sense, so it can be just revolving around in multiple directions. It changes time to time. So it is not uniform velocity because the direction is always going to change. Not uniform, not uniform. Have to remove the first two answers. Changing velocity, yes and yes. But what law? In this question, Newton's first law is not relevant, but I'm just going to mention in the Newton's first law, an object might be revolving, so moving at velocity of v or just be stationary. But Newton's second law of motion. What about the rate of change of momentum is directly proportional to the force applied. That means the force is directly proportional to the change of momentum. And we know change of momentum is nothing other than m delta v, change of velocity. Here there is a change of velocity. It's going to be Newton's second law. So my answer is C. Right. In the same way, a sphere of weight 2.5 Newton float on water with half volume beneath the water surface, half the volume. Right. So the next part is just open. Now here, so the first part is just gone, and you have to immerse the next part by pushing certain extra force. What is this force? The weight is equals to V rho G T. So the volume is V over 2 here. So the force equivalent is 2.5 equals to what? Proportional to what? V over 2. What is the next half? If you just want to immerse the next half, it's also half volume. So the force should be equal. So it's 2.5 Newton itself. In the very next question, a ball rolls off a table with horizontal velocity of 1.2 meters per second, and ball takes 0.9 seconds to reach the ground. So it takes some kind of path like this, but don't want to consider that part because why? Have to only consider horizontal motion only, because something which is moving at horizontally, right? So let me just do it like this way. So simply an object moving in a certain linear path. That's what it is, because the horizontal component remains constant at each point. It is going to be the same value, same value, same value of 1.2. And you know the time taken, so you have to apply to the equation of s equals to ut plus half at square. So the at is 0, so acceleration is 0. S is going to be what? U is at 1.2 into time is 0.9. The answer is this one. That's it. Okay, let's go for the next set. So in this one, the sample of seawater is collected using a beaker. So a beaker contains some particles of sand, which is settled to the bottom of the beaker. If there is a beaker and a certain amount of water there, so there is a height. So there's a height here. So it decrease the time. If there is a particle which is traveling with velocity of v, what should be the velocity and the height relationship? Velocity is equal to distance over time. So as to have a lower time, it should travel faster. Isn't that? Have to lower time is to travel faster. Which one gives the here is a falling part. That means there's a thing called terminal velocity. If it has a higher terminal velocity, travels faster. Travel faster. Which one allows you to have a higher what? Terminal velocity, because terminal velocity equation is 2r squared g minus d minus rho over 9 eta. Constant is one nothing to consider constant. So only radius and eta can be changed here. So smaller particle of sand means lower radius. So what about the radius? Square. So that means smaller change of velocity will increase to higher in the velocity radius. So here the velocity will increase rapidly. So smaller particles not help because the terminal velocity is still very low. In the next part, lower temperature of the sea water, right? Lower temperature of the sea water means that according to the water, right? Liquid. In liquids, what about eta reduces with the high temperature. As the temperature is high, it lowers the viscosity. So here technically, it's not going to help. So wait. Lower temperature means it's going to increase the temperature. So not going to help because once the temperature viscosity increases, velocity reduces. So the smaller terminal velocity, no, have to have a really high. That's what I was talking about so far. Lower viscosity of water definitely increase what? Because velocity is inversely proportional with viscosity coefficient. Lower viscosity means higher terminal velocity. Higher terminal velocity means this travels really fast downwards. So the answer is D. In the next part, right? Really good question. In the next part, it talks about what? Stress, sigma, and the strain E epsilon. So what is it going to be? Right? Epsilon and sigma. Oh, what about here? So sigma or epsilon. So have a look at. There are four things, A, B, C, D, and both low elastic limit, and large region of plastic deformation. Right. Large region of plastic deformation. This one has a large deformation. This one has a large deformation. Yes. And how about the elastic limit? So these two have only what? Very lower plastic deformation. See? And think about the what? Very low elastic limit here. So higher elastic limit over this one, and low elastic limit means both of them have the low elastic limit. These two have really high elastic limit. How to eliminate? And this one has a very low plastic deformation. This one has a high plastic deformation in this region. So definitely answer is C. Answer is going to be C over here. Right. So let's move on to the next part. Discussed here. Yeah. What the heck? Okay. Technical fault occurred previously. And the seventh question, it's like, what is it? Pump causes what? 20 grams of water to ejected from a nozzle of garden hose in each second at 3 ms minus 1. Right? Which of the following expression is the power? So what is the meaning of power? The energy over time. Here it says per second. Per second means 1 second. The time is already included in that sentence. So you just need to play that. In that case, E in some under some conditions per second. So what is the kinetic energy? Kinetic energy is going to be half mv square. Yeah, mass is 200 grams. That means 0.2, and the velocity is going to be 3 square. So the answer is B, 0.2 v squared over 2. That's it. In the 8th question, it says like a really good question. A model rocket is launched at moves vertically upwards while still burning fuel to give a constant upward thrust. Really good question in that sense. It is just moving like this upwards under some certain constant acceleration because of the thrust provided by the engine, right? So according to acceleration time graph, it is supposed to be, wait, an acceleration time graph is something like this way, right? Okay, I'll extend. So have a good look at, so constant acceleration and use the thrust, and the fuel runs out. Now what does happen? Once the fuel run out, what will happen to the object? Will that object just fall all of a sudden? No, it won't. It may travel. If at this point it happened, imagine at this point it happened, it says it reached to the maximum height at time t before falling back, right? This is what t. So at this point, somewhere in t, the fuel ran out. So will that rocket going to decelerate? That means fall down once the engine shut off? No, because why? It had some velocity of initial velocity of u at the time. It moves like a vertical projectile now, reach here and just comes down. So at the right at that time only it is going to come down. That means it should be somewhere behind t it happened, because it reached the maximum height at somewhere t, not on t. These two graphs are not tallying at all because it's not a constant acceleration. So this has to happen before t, and once the engine is ran out of fuel, no thrust against the gravity, only the gravity going to apply from that moment onward. The only tallying graph is C, not this one, because in this one it says it happened exactly at t, but it is not true because it has to move somewhere up and stop and come down. So this is not. Again, right. Let's move on to the next question, next set of questions. So this one, we can do it in some few ways. I will show you the most conventional method. It's like to complete the vector triangle. This is some vector. Draw this longer vector. And your resultant is going to be here. Only one represents that. That's the answer. B here. Small arrow tilting to down right hand side. There's another one method, because now it's like tricky. So see, if I just consider this one as a vertical vector, right? It's a vertical vector, longer vertical vector, and a downward one like a shorter vertical downward vector. The resultant should be somewhere like here. Now considering the horizontal vector, this one is more tilted to right hand side than this one to left, so it should bend somewhere bit right hand side. It's like this. Without drawing the vector triangle, you can also get this answer. This is some alternative method. Okay, this is an alternative, right? And let me explain you the very last one. In the very last one, it is like an object upwards, acceleration of A on a lift. So I will just draw the bottom of the lift and a person standing on there, he experienced the reaction force of reaction R1, that of what? 800. And there is the downward force, that is the weight of the guy. It's like some 70 G, because all the answers are given in G and A, right? So it's like 70 G. Now, what is it going to be? The force which is going to accelerate the guy at the acceleration of A. So there should be a reaction resultant force, that of R2. How to write? R2 in the upward direction, because this one is greater. R2 is equals what? R1 greater 1 minus W weight. Right. According to Newton's second law of motion, this is going to be what? F equals to ma T. This is what the reaction. So what can I write? Ma is equals to R1 is like 800. It's given minus 70A. So the only answer that tallying this one is C. Answer C. This is what all about the first 10 MCQs. In the next video, I'm going to explain you how to solve the other questions. All the other questions will be in the next video.